We're looking at the Math 2 Unit 3 review. The first set of problems are from the chapter review at the end of the chapter in your book, and then we add some set on to that for some additional practice. So let's just go through and start naming some congruent statements. I have RSTUV, KLMNO. They're five-sided objects. I'm not even going to draw them. I'm just going to look at the names to see if they can help me identify the corresponding parts. So if I look at the first one, TS is a segment, so I know I'm looking for a segment. TS is the third and second letter, so I'm going to go third and second and call it ML. Angle N is going to be corresponding to the fourth letter over here, which is angle U. And then LM is second, third, so I'm going to go ST. And then VUTSR, looks like I start VUTSR and just go in reverse order, so it's going to go ONMLK. Now we take that same idea and look down at 5 through 10, where we now have corresponding objects. And so let's match up some parts. Now before I go through and name these, I'm just going to look at the picture. I have WXYZ PQRS. So I can match up corresponding parts. If I have 10 here, this side is 10. 8.6 goes to 8.6 here. 5 and 5 match. W is corresponding to P, so I'm going to make the 80 right here. And then the 145 at Y is corresponding to R, so 145 here. So now I have, let's bring the rest of it over, 35 and 100, all my parts labeled using corresponding parts. So it's just going through finding the information. So angle P would be 80 degrees. Length of QR is going to be, we didn't write that one should be a 3. WX is here, that one is 5, it was corresponding to QP. Angle Z is 35, that was corresponding to S. Angle X is 100, that was corresponding to Q. And then angle R is 145, that was corresponding to Y. For 11, if we have triangle HFD, what angle is included between DH, this side, and DF, this side? Well, the angle included between them would be angle D. I could also call it angle HDF, or even angle FDH. A good hint for that is when we're talking about an angle included, it's going to be the common letter between the two, DH and DF, so that's where we get angle D. So for OMR on number 12, what is between M and R? That's going to be this side out here. That'll be side MR, which notice is the side that is made up with the letters of M and R. Now for 13, when you're going, which postulator theorem, if any, could you use to prove the two triangles congruent? So we'll go through and label what we can find, maybe add to it. I start with 13, two sides here. I know that this side is congruent in both because it's reflexive property. But unfortunately, that's not enough. I don't have anything else to use, so I'm going to do not enough information. I need 3 sets of congruences to work. 14, same idea. I have a set of angles, a set of sides, but that one is fortunately not enough information. 15, though, I have vertical angles, and those are congruent. I have 2 sets of sides. So my 2 congruent triangles would be here, and it would be side, angle, side, because the angle right here is between the 2 sides. When we look at 16, I have 2 angle pairs, the outside and the bottom here, and I have the side between them. So 2 angles means it's either angle, side, angle, or angle, angle, side. Now we've got to be careful when we pick them. In this one, here's my 2 angles. It's not, the side is not the one between them. It's the one over here. It's not the one included. So it's not going to be angle, side, angle. It's going to be angle, angle, side, because here's our 2 angles, and the side, the S, is not between them. For 17, how can you use the triangles to prove the statement true? So same idea we just had. We need to make sure we know the congruence, and then we're going to do that extra piece to show that the triangles or the pieces are congruent. So if we look at my 2 triangles in 17, I have angle, angle, side, angle, angle, side. It's not angle, side, angle because, again, the side is not between the angles. So this shows that the triangles are congruent. And then the fact that TV is congruent to YW is because that corresponding parts of congruent triangles are congruent. So since the triangles are congruent, we know that all the leftover parts, TW and YW, or TV and YW are congruent as well. 18, I have reflexive property for CE. It's congruent in both. This means it's going to be angle, side, angle to show that triangle BCE is congruent to triangle DCE. And then I would know that BE is congruent to DE because, again, corresponding parts of congruent triangles are congruent. 19, we have reflexive property again for CE. I now have that triangle BEC is congruent to triangle DEC. And this time it's going to be by side, side, side because I have all three sets of sides. And then angle B is congruent to angle D because corresponding parts of congruent triangles are congruent. For 20, we have reflexive property for KM. And then we have these parallel sides. Parallel doesn't mean congruent. Now, the sides are congruent. It does tell us that. But whenever we see parallel, I want you to look for either alternate interior angles or corresponding. And I get the alternate interior here because if we drew it kind of extending the lines out, that is what alternate interior angles look like. They are congruent. So we have triangle, go KLM is congruent to triangle MNK. And this time I have two sets of sides, angle between, so it's side, angle, side, and then KN is congruent to ML by corresponding parts of congruent triangles being congruent. For 21, we're looking at an isosceles triangle. Now, these markings tell us the sides are congruent, which also tells us that x is 4 units. And now when it comes to the angles, since it's isosceles, I know that the base angles are congruent. So it's almost like I have two y's here. So I have to go y plus 50 equals 180. 2y plus 50 equals 180. 2y equals 130, so y is 65. For number 22, I'm going to use the fact that x and 125 are a linear pair. That gives me that x is 55. I'm going to go vertical angle to put it here in this smaller triangle. And again, like over at 21, y is congruent to this other base angle. So I have two y's here. 55 plus y equals 180. Or 55 plus 2y equals 180. That gives me 2y equals 125. So y is equal to 62.5. For number 23, we have base angles, again congruent. So let's do this. Let's treat this as a big isosceles. So this is going to be 50 here, because 25 and 25. That means, like over here, when I had the 50, these two angles were 65. This would be 65. This would be 65. So x is 65 degrees. Now in that triangle with y, I'm going to break it apart again. I got 25, 65, and y. Well, 25 and 65 together is 90. If there's 90 degrees already in the triangle, left over for y is going to be 90 degrees as well because it has to add to 180. We also could have looked at this and said, well, it kind of looks like it's cutting in half and is perpendicular. It actually was in that case, but you want to be careful not to use the fact that it looks like it. We can still go through and solve. We got x is 65, y is 90. For 24, it's an equilateral triangle, so that means x is also 7. All sides are the same. If it's equilateral, it is also equiangular, which means all the angles are the same, so you could do 180 divided by 3 and get 60 degrees, which would be angle y. In fact, in any equilateral or equiangular triangle, the angles will always be 60 degrees. Now for 25, we need to prove the two triangles congruent. So I'm going to start out with my given information. LN is perpendicular to KM, and KL is congruent to ML, both given. My goal is to get the two triangles to be congruent. So far I have these two sets of sides here. It's a good start for us. Let's go here next. So I got a side, LN, in both triangles, and LN is congruent to LN, and that is reflexive property. And now, if we're looking at it, well, I got two sets of sides, and I got this angle. And I kind of know if that's a right angle, then this is also a right angle. But we got to be careful in how we say this. We got that's a right angle because LN is perpendicular to KM. So let's write that angle KNL and angle MNL are right angles. Now we know this because that's the definition of perpendicular lines. It's almost as if I asked you, okay, it's perpendicular, what does that mean? Hopefully you're telling me there's right angles there. So it looks like we're going to a triangle congruence. Now we're not going to call this side-side angle or angle side-side because that doesn't work for us. There's one in a special case that we have when we have right triangles that the hypotenuse leg theorem works. So if I look at my right angles here, hypotenuse opposite the right angle, those are congruent, and I have a leg, the side adjacent to it are congruent. So I'm going to go one step further and say, well, you know, if they're right angles, aren't they congruent? So we're going to go KNL is congruent to angle MNL, and that's because right angles are congruent. So now I can name the two triangles KLN and MLN are congruent by hypotenuse leg. We are not going to call it angle side-side. We are not going to call it side-side angle because that doesn't work in all cases. This is a special case. Because it is a right triangle, we can use hypotenuse leg. All right, now let's look at 26. So we have PS is perpendicular to SQ. We also have that RQ is perpendicular to QS. As well as PQ is congruent to RS. Now anytime I get these proofs, I like to look for easy properties I see right off the bat. I see that QS is congruent to itself. That is reflexive property. And let's look what else we have. So this is actually kind of looking a lot like 25. I have perpendicular again, so let's do this. Let's make sure we call these right angles. So we're going to go angle PSQ and angle RQS are right angles. And that's the definition of perpendicular lines. And then if they're right angles, I'm going to say that PSQ is congruent to angle RQS because right angles are congruent. And now I have the special case of any right triangle. When I have right angles, the hypotenuses are congruent. There's a set of legs congruent, so I can use hypotenuse leg. And I would name the two triangles PSQ and RQS as given above for what we want to prove. For 27, we need to name a pair of overlapping triangles we have and identify the congruence for how they work. So anytime we get two overlapping triangles, draw them separately. So I'm going to draw AEC. I'm going to draw ABD. And let's see what we know. So I got AE is congruent to AB. I got AD, AC. I have this angle A up here is congruent to this one. So in separating them, I didn't really have an overlap like a reflexive property. There's kind of gaps between them, but this is enough here. We're going to say that it's side, angle, side congruence. two sets of sides, and the set of angle in between them. For 28, I'm going to separate them. I got FIH. I have GHI. I have FI is congruent to GH. I have right angles. I have IH is reflexive to IH. So this one is also going to be side, angle, side. For 29, let's do PST and RAT. So we got angle A, angle S, looks like AT and ST. And then the reflexive property here would actually be angle at T. That's congruent in both. So in this case, our triangles now are going to be congruent by angle, side, angle. I have a side in between two sets of angles. Now we're on to the extra problems. These are not going to be found in your chapter review, but they are hopefully in your packet. For number 30, we have two triangles. Let's draw these out. I have AD and BC intersect at X. So let's put X, AD, B, oops, BC. Okay. AX is equal to BX. So we got that. CX is congruent to DX, okay, and we have triangle AXC and BXD. So now we got our two triangles, and we need to figure out how they are congruent. Well, we have those two sides, and that's a good start. We don't know that AC and BD are the same, but what we do know is we get vertical angles there, so this will be a side, angle, side congruence. For number 31, we need to find angle X. We need to find what's corresponding to X. So if I look in this name of it, X corresponds to E. So over here, I don't know the value of E yet, but 60 and 90 is 150, which from 180 leaves us 30 left over. So 30 goes to the X. We're going to call it 30 degrees. For 32, we need to prove the two triangles congruent. They want to know which one we'd use. We have two sets of angle pairs. That's a good start. Quick one we got is reflexive property, shared side between the two. So we're going to go not side angle side, it'd be angle, side angle. 33, an angle formed by the legs of an isosceles triangle. So the legs in the isosceles triangle are those two. We need to know what this angle is called. Now it's not the base angles. Those would be the ones, there's multiple of them and not just one. It'd be the one at the top. We call it the vertex angle. Now for 34, we need to go through and make sure we're reading these statements correct to find the right congruence. So if two sides in an angle of one triangle are congruent to two sides in an angle of a second triangle, then they're congruent. Now here's the problem with that. This could be side angle side, or it could be angle side side. This one does not work, that one does. We don't know for sure which one they're talking about. They didn't specify, so we're not going to use it. It's too broad. There's not enough specifics there. For B, if two sides in the included angle of one triangle are congruent to two sides in the included angle of a second triangle. So now it's saying, all right, we got two triangles, two sides and the angle between them. Now it's looking like side angle side. We can be good with that, but let's keep going. If three angles of one triangle are congruent to three angles of a second triangle. Now if I had just angles, that is not enough to guarantee congruence, because maybe it's a small triangle with those angles, maybe it's a big one that we don't have one to match, so that one's wrong. And then D, a right triangle is isosceles. Well, I could draw a right triangle that looks like this. It could have a right angle, but I know for sure it's not isosceles, not in all cases, so B is our best answer. Now we look at 35. Which of the following sets of information does not allow us to conclude the two triangles are congruent? So we're going to need to draw them out. So I'm going to draw, we're going to go A, B, C, D, E, F. This is our answer for A. We're going to see if it works. So we got AB, DE, BC, EF, and AC, DF. That looks like side angle side. That but we want does not. So that one is safe, that one's going to work. Well, B actually is all angles, and up here we said you couldn't have all angles, so that is probably a very good candidate. Let's check the rest of them just to be safe. Got A, B, C, D, E, F. Got A, B, D, E, B, C, E, F, and then angle B, angle E. That looks like a side, angle, side. That one's looking safe. And last, D. I go A, B, C, D, E, F. We got right angles, A, B, D, E, B, C, E, F. That looks like a hypotenuse leg, so it looks like B would be the incorrect answer. For 36, what can we use to show the two triangles congruent here? I have two sets of angles. Since that's the case, I know B and C are automatically gone. It's between angle side angle and angle angle side. Our answer will be C because the side is not between the angles. For 37, I look at this problem and I instantly think, oh, I'm just going to add a reflexive property to that because it shares a side. In this case, I have two sides, one angle. Now, if I have two sides, one angle, answers B and D are automatically gone. HL could work, but I would need a right angle. I don't have a right angle. Side, angle, side, two sets of sides, angle between. We're going to go with answer C. For 38, what is the length of the leg? Now, we got to do a little bit of work with the angles first to figure that out. 45 and 90 actually add to 135, so you're going to get 45 degrees left over for this angle here, which makes this an isosceles triangle. So I'm going to say 3x plus 4 equals 7x minus 8. So when solving, subtract 3x from both sides. I'm going to add 8 over. I get 4x equals 12, so x equals 3. Now, they didn't want to know what x is, they want to know what the length of a leg. So I'm going to plug 3 back in and see what I get. 3 times 7 is 21, minus 8 is 13. I could also have done 3 times 3 is 9, plus 4 is 13. 13 is my answer. Be careful on the setup for this one. You should not be adding them adding them up, setting them equal to 180 because they are sides, not angles. Now 39 is looking at angles, and we need to classify it by the angles. I look at this, I'm not trusting it to be in the scale. I'm going to take the values that I know, add them up, and set it equal to 180 to see what I get. So I got 8x plus 20 equals 180. Gives me 8x equals 160, or x equals 20, which by itself doesn't tell me anything. But when I plug it back in, I get 20. 3 times 20 is 60, plus 10 is 70. 4 times 20 is 80, plus 10 is 90. Now looking at it, it is not a acute triangle, it is a right triangle because I have the 90 degrees. For number 40, this is isosceles, so I know the base angles are the same, so I know those are both x. I could do 110 plus 2x's equals 180, or 2x equals 70, and so x is 35. D is my answer. In 41, we're translating the point 4 units to the right. Now, if we move 4 units to the right, that moves it in the x direction and in the positive x direction. So we need to find the one that has x plus 4 with y staying the same. So we're going to go with answer C. 42, we need to describe the transformation from GHJ to GHJ, or the image of that. Now if I look, notice how the orientation of it is the same. G is on top, H is to the little bit down to the right, J is on the bottom. Same here. So it's like they took the whole thing and they shifted it down. It's not flipping over and changing the orientation. So this is actually going to be a translation where G went from the point 1, 1, 6 to 1, negative 2. And in that case, the y value actually went down 8. So we're going to go with D. Now, what C would have been is C would have been a shift left 8. So we got to be careful with that when we change the x direction, and we already said it was not a reflection. 43, we're looking at a rotation of 180 degrees in the counterclockwise direction. What we can do for a 180 degree rotation is notice that we went over 3, up 4. We're going to do the opposite directions of that. We're going to go left 3, down 4, and that it's going to be at the coordinate -3, -4. For 44, we want to move this point of A to 0, 0. So we want to go 4 to the right, up 2. So that means we're going to take our point and we're going to add 4, add 2. So add 4 to x, add 2 to y. Our answer will be A. For 45, we need to find the angles. So let's first just look in the isosceles. I got 50 here. That means I got 130 left for both of these angles. So if I divide that by 2, each of these angles are 65. Okay, so if that's 65, and I know that, well, 65 plus this has to add up to 180. I'm going to say 5x plus 105 equals 180. 5x equals 170, oops, not 175, just be 75. So x comes out to be 15. So we got x, classified by its angles, that's going to be an acute triangle as well. 46, it is equilateral. If we know, or not equilateral, is isosceles, got ahead of myself. These two sides are the same, so I'm going to say 54 equals 9x. So that means x equals 6. This is an isosceles, because we have two congruent sides. 47 will be an equilateral, all sides being the same. Now we said earlier that when it's equilateral, the angles are all 60 degrees. So I'm going to do 5x equals 60 and get x equals 12.